Okay. So today we have Fury Thursday. Thursdays, what theories do you have about me? I know the other guy here. Theory Thursdays. For Theory Thursdays, I believe that the reason why most of my kids do not understand their formulas is because they don't understand what do we mean when we say something is directly proportional or inversely proportional. Okay, let's talk about it. What do we mean? Okay, and I'm going to show you this in a different way. So what do we mean when we say that A is directly proportional to B? We mean that if A was to increase, then B is to also increase. We're not saying that they will increase with the same amount of value, but the proportionality in which they increase should make sense, right? Let's take a look at this in terms of Newton's law. So we have Newton's second law that tells us that the acceleration is directly proportional to the resultant force. This implies that if my resultant force was to increase, then my acceleration should also increase. Right. What does it mean when we say inversely proportional? It means they work in opposites. So if A is inversely proportional to B, when B increases, then A should decrease. Oh, I'm my students. Sorry. Let's fix that. So when B increases, this must then decrease. Okay. Example using Newton's third law. It says this is directly proportional to. So it says it's inversely proportional to the mass. Meaning, if my mass was to increase, the acceleration should decrease. And that should make sense. And the opposite is true, right? If I were to then decrease my mass, then I can move a little bit faster, so my acceleration should then increase. Right. Let's look at this with regards to values. I think when we put values to numbers, it makes sense. Let's say we want to calculate the acceleration and we have a resultant force of 10 newtons and we have a mass of 5. I can see here that my acceleration would be 2 meters per second squared in the direction of my resultant force. So let's go ahead and then test out this theory that acceleration is then directly proportional to my resultant mass, my resultant force. Let's say I increase the force and I have now a force of 20 newtons. I would then get an overall acceleration of 4 meters per second. So my force doubled and so did my acceleration. That's the proportionality coming into place, right? They are directly proportional, directly implying when one increases, the other one also increases, but the proportionality also talks about their magnitude. When I double my force, I double my acceleration. Let's look at changing the mass. So if I were to keep the same situation here, where now I have that 10 Newton force, but I'm going to go ahead and decrease my mass, I would have 10 over 2 giving me 5 meters per second. So the proportionality in which my mass went to 2 would be the same in which my acceleration went from a 2 to a 5. But it's inversely proportional. By decreasing my mass, I have increased my acceleration. Okay, hope that makes sense.